Let's continue with balancing chemical equations. In part 1, we have seen how to balance a chemical equation. And here we are in part 2. Let's solve some questions. The first question is a reaction between zinc that is in solid state reacting with the hydrochloric acid in aqueous state. The products are zinc chloride and hydrogen gas. Let's check whether this equation is balanced or not. As we discussed before, we have to count the number of elements on the left hand side and the right hand side of the equation. On the left hand side we have one zinc, one hydrogen, we have only one hydrogen and one chlorine. So we wrote like this. If the right hand side has the same number of elements, then the equation is balanced. Otherwise it's unbalanced. We have zinc 1, zinc mesh with the zinc on the left hand side, so it's fine. Let's look at hydrogen. Hydrogen on the right hand side we have 2 hydrogen, so the number of hydrogens on the left hand side and the right hand sides are not equal, so the equation is already unbalanced. Let's check the number of chlorine. On the right hand side we have 2 chlorines and the left hand side we have 1 chlorine. So the problem is with chlorine and hydrogen. You see here you have 1 chlorine, right hand side 2, left hand side 1 hydrogen and right hand side 2 hydrogen. So we have to come to the left hand side where the number of hydrogen and chlorine are less than the one in the right hand side. So we need to think how to increase the number of hydrogens here. The only way you can do that, to put a coefficient here. Let's check if you put a coefficient 2 here, what happens to the number of hydrogen and chlorine. Now this 2 belongs to both hydrogen and chlorine. So after you put the coefficient 2 here, the number of hydrogen is no longer 1, it becomes 2. Number of chlorine is no longer 1, it became 2. So now look at the number of elements on the either side of the arrow. On the left hand side you have one zinc right hand side, left hand side you have 2 hydrogens, right hand side you have 2 hydrogens, left hand side you have 2 chlorine, right hand side you have 2 chlorines. This equation is balanced now. It's look easy, you should learn like this. This is a simple method, and to understand it better, let's do another question. I have another question with me here. It's also not a difficult question. Here we have silver bromide, that is in aqueous solution, gallium phosphate, that's also in aqueous solution, silver phosphate in aqueous solution, gallium bromide, that is in aqueous solution. So all 4 compounds are solid state. If they are in solid state, difficult to involve in chemical reaction. That's why they are dissolved in water to form aqueous solutions. Okay, the normal procedure is, let's check the number of elements on the left hand side and the right hand side. Let's start with silver here, Ag. You can see 1 silver here, and bromine, Br, is 1, Ga stands for gallium, and P, you have to split this P and oxygen. They are 2 different elements. Phosphorus 1, oxygen, we have 4 oxygen here. On the right hand side we have 3 silver. Look at Ag3. So the equation is already unbalanced. Then bromine, I'm following that order, that the order of the left hand side. Bromine is 3, then gallium you can see it's 1, Then the next one is phosphorus. Phosphorus is 1 and oxygen is 4. Silver 1, silver 3, bromine 1, bromine 3, gallium 1, phosphorus 1, 1, oxygen 4, 4. So the problem is with silver and bromine. Silver and bromine are together here, so that makes our question an easy question. So here you have 3. So how can you make this 1 into 3? That is our question. So if you put 2 here, if you put 2 here, your silver will become 2. Actually, we need 3. So let's try with 3 this side. So this 3 belongs to both silver and bromine. So now if you count the number of silver here, silver is 3 now. Right hand side it's 3. Bromine is 3. I repeat, this 3 is for both silver and bromine. Now bromine is 3. I didn't make any change here. Gallium, phosphorus and oxygen falls here. I didn't make any change, so that number remains same as it is. Now you can see that silver 3, silver 3, bromine 3, bromine 3, gallium 3, gallium 3, phosphorus 3, phosphorus 3, oxygen 4, oxygen 4. You can see that on the either side of the arrow we have equal number of elements. I mean a particular elements. So the equation is balanced. That was a nice question. Let's check another one. I have another question here. Here we have zinc sulfate, that is in aqueous solution, lithium carbonate, that is in aqueous solution, zinc carbonate, that is in aqueous solution, lithium sulfate, that is in aqueous solution. Let's check the number of elements on either side of the arrow. Let's start with zinc. Zinc, we can see that it's only 1. The second one is sulfur. Sulfur is 1. Oxygen here, I have 4 oxygen. Then lithium, 2, carbon, 1, and I have 3 oxygen this side. So I cancel them and write as 7. 4 plus 3, 7 oxygen. We need to write them together. Then on the right hand side we have zinc. We have 1 zinc. And the second one is sulfur. Let's follow that order. Sulfur is 1. Then carbon, lithium. Lithium is, we have 2 lithiums. Then the next one is carbon. Carbon here, it's 1. And then we have oxygen 3 here and oxygen 4 there. So we need to write them together. We have 7 oxygen. So let's have a look at on the left hand side and right hand side. Zinc 1, zinc 1, sulfur 1, sulfur 1, lithium 2, lithium 2, carbon 1, carbon 1, oxygen 7, oxygen 7. This equation is already balanced. I choose this question intentionally. So there are questions or equations, they are already balanced. Sometimes the learners think that equation is not balanced and you try to fix that equation. So thank you.